Hello students, let's start our KIDWIZ page number 53 and 54. Here in the first part there is we have to find the odd one out. So there are 5 subparts of part A. So let's do the first one. So here they are given the sequence A1Z, B2Y, C3X, D4Z, D4W. Now clearly look, then first alphabet, that is A, B, C, D, D. Okay, that is the direct ABCD. Then 1, 2, 3, 4 as it is. Now look, Z, Y, X, Z, W. Now what here? The ABCD from the last. So what came before Z? That is Y, then X, then W. So this is the odd one out. Okay, let's move to part 2 here. Now look, the arrow of the direction first goes this side, then this side, then this side, then this side. The next should be in this direction, but it is in straight direction. That's why this is the odd. Now let's move to third part here. Now the answer of this figure is this, but let's see how we find it. Now look, there are 4 vertices or 4 edges, 4 sides, and here 3 sides. Here 1, 2, 3, 4, 5 sides, 4 sides. 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5 inside. Means here the outer figure has one more side than the inner side. But in second part there is not like this. That's why this is odd. Okay. Let's move to fourth part here. Now these first and second, these are the mirror images. Now the mirror image of this is this one. So the answer odd one out is this. Okay, mirror images. This is based on the mirror images. Now let's move to fifth part here. 1, 2, this is divided by these 2 lines. Now this line is 1 line rub. Here 2 lines, 1 line gone, 2 line gone. Here there should be 3 line gone, but there is only 2 lines. So this is the odd one out, because this here it should not be here. So this is the odd one out, because the number of lines or number of partitions are going to decrease. That's way. So let's move to B part here. Join the 2 rows of dots to make squares and triangles. How many can you make? So let's find out how many squares. Or so first one, join these, join these, join these. So 1, 2, 3, 4, 5. Okay, so there are 5 squares. Okay students, so there are 5 squares. How many squares? 5 squares are there. Here, here, and we can also join this. Now we have to count how many triangles. First let's see a single square like this one here. Let's see this square and join this. Let's see how many triangles in there. So there are 1, 2, 3, 4, 4 small triangles and 4 big triangles, like 2 on this diagonal, 2 are these. I will show you like this, and this, and 2 are these. I hope you understand. This is very messy, so let me clear it first. Let me show you once again. Let me try to show you. This is a square, this is a square, and this is the diagonal. Now small triangle, small, these all of you can count. This is the 4. But now let's see here. This is 1 and this is 2 on this side. Also there are 2 are these sides here. So 4 plus 4, the answer is 8. So means there are 8 small triangles in each square. Now the trick is, means you have to count those. There is a trick to count the number of triangles. That is, count the number of squares. That is 4, that is 5. So always minus 1. if there is shape like this, minus 1. So 5 minus 1, that is 4. And in each square, there are how many triangles? That is 8. So there are 48 triangles in this figure. Remember that this is the trick, okay, students? You can easily 8 plus 8 plus 8 plus 8 plus 8 and one more like this. They are going to increase by one like this also. So there are total of 48 triangles, okay? The answer given in the back side is wrong, so don't compare that. There is only, I think, whatever it is, but that is wrong. So correct answer is 48, okay? So there are 5 squares and 48 triangles. Now C part, observe the table along horizontal and vertical lines carefully. Locate the number you want to multiply in the vertical column and other in the horizontal column. The number at the intersection of the column given the answer. Okay, means let's see, for example, you want to multiply 4 and 5. So 4 and 5, they intersect at the 20, so 20 is the answer. 4 5s are 20. Similarly 8 and 7, so 8, here 7, so answer is 56. That's about this table. Now let's see the D part here. The oldest mathematical puzzle dating 1650 BC. As I was going to St. Ives, I met a man with 7 wives. Every wife had 7 sacks, and every sack has 7 cats. Every cat has a 7 kittens. Kittens, cats, sacks, and wives. How many were going to St. Ives? So, how many goes? Think about how many? The answer is only I was going. Okay, they met them. All of these they met them in the met me. Not they are going to St. Ives. So who was going? How many? Only one person. That is I am me. Okay, he was going to the St. Ives. That's all about these 2 pages. Thank you.